So, let's begin by asking, what is credit scoring? Credit scoring simply is a statistical analysis performed by lenders and financial institutions to access a person's credit worthiness. Now, you may ask, why do financial institutions do this? Lenders use credit scoring, among other things, to arrive at a decision on whether to extend credit or not. Now that you're curious about credit scoring, you may wonder, how are movements in credit scores measured? These tools are called measures of separation or measures of divergence. They are used to determine differences in data distribution during course classing, variable selection, segmentation, result evaluation, post-development validation, or post-implementation monitoring, some of which are part of the credit scorecard development process. Chi-square, Kullback divergence, Spearman's rank, Gini coefficient, and K-statistics are some ways of measuring separation or divergence. Today, we'll be focusing on chi-square. Chi-square is a method used in statistics that calculates the difference between observed and expected data values. It is used to determine how closely actual data fit the expected data. The value of chi-square helps us to answer the question, is the difference in expected and observed data statistically significant? The formula is simple. It is the summation of the squared observed frequencies minus expected frequencies that divided by the expected frequencies of all categories or classes. The null hypothesis in chi-square is that the observed frequency distribution fits the expected frequency distribution. Now, the alternative hypothesis is the observed frequency distribution does not fit the expected frequency distribution. I know, it's not as simple as I said it would be. So let me explain this to you with an example. Suppose we purchase a bag containing 200 M&M candies and the manufacturer claims that the bag contained 30% red, 20% brown, 10% yellow, 20% green, and 20% orange candies. After opening the bag, we make the following observations. Now, let's use the chi-square formula to calculate the chi-square value. So, after calculating the formula, our chi-square value is 26.6. Now, we compare this calculated or simple chi-square with the chi-square distribution table or theoretical chi-square. Since there are 5 categories of colors, we look up the chi-square curve with 4 degrees of freedom. That is 5 minus 1. Suppose we are testing at the 5% confidence level. We can see from the table that the critical chi-square value is 9.487. Since the calculated chi-square value is greater than the critical chi-square value, we reject the null hypothesis and the manufacturer's claim regarding the distribution of colored candy in the bag. In credit scoring, the most obvious uses of the chi-square test are 1. To measure the drift in score or characteristic distributions over time, and 2. To measure the differences between the good and bad distributions. In these cases, contingency tables are being compared and the rules for calculating the degrees of freedom changes. Let's see an example if there are any differences between historical and current good or bad odds. We are given data of historical, current, and expected data of different groups. Since the estimates are the recent row totals, the degrees of freedom is 4. Now, the chi-square value is 22.9. With 4 degrees of freedom, the critical chi-square value at 95% confidence is 9.48. Since chi-square is greater than the critical chi-square, we reject the null hypothesis, which means the difference between historical and recent odds cannot be considered random. There are 2 particular instances where the chi-square statistic can be used as part of the scorecard development process. One is in the course classing, and the other one is on variable selection. So now you know how chi-square is used in credit scoring. Thank you for watching. This is Group E, and stay tuned for more videos of MPD Academy.